Okay, so on the top of page 152, just some little diagrams. Okay, so again, the white bit is the land, the blue is the sea. All right, you had your river, so the sea level's dropped. You have your river valleys, the river's flowing into the sea here. Okay, then the sea level rises, and they fill in the lowest parts of the land where the rivers are. Okay, so they backfill in, and here's your rias. That's what they look like. Okay. Going to just move down to fjords, moving on very quickly. Fjord, again, I've just put in the spelling with the J. Alright, when the coast of a glaciated highland, so when the land with a glacier on it is submerged, the lower part of the trough, or the lower part of the land, is drowned to form a fjord. Okay, now the sides of a fjord are very, very steep, and the depth of the water may exceed 1,000 meters, so these are much more dramatic. Okay, a ria is kind of a gentle slope into the ocean, whereas the fjords are very dramatic. I'll show you some pictures shortly. Alright, some good examples, again, Norway and British Columbia. Now if you think about where those places are in the world, they're both near the North Pole, so they would have experienced huge ice sheets that would have compressed the land down massively during the ice ages. Okay, just going to pop up onto the next page and show you some pictures. So I think this is pretty self-explanatory. Again, you got the ocean, and here's the land. Okay, during the ice age, a huge glacier moves down here. These have huge erosive power. Okay, so they push everything out in front of them. All right, and then when the ice melts, the sea levels rise, and they backfill in all of this. All right, and that's what you have. Also, quite commonly, the water backfills in all of this region here. Quite commonly, what you'll have is at the entrance to a fjord, okay, is quite shallow, because the ice scoops out all of the land here, but then it floats on the sea here. All right, so you actually have quite a shallow entrance, but then a very, very deep channel of water. Like we said, it can be over 1,000 meters deep. Okay, so I'll show you some pictures of that again. What we're going to do is we're going to jump over to New Wider World and just look at some differences between rias and fjords to kind of summarize it. Okay, so I'm on page 303 of New Wider World. I've added in my bonus pages here as well. Okay, so after the ice age, the sea level rose as the ice and snow melted. Many coastal areas were drowned, okay, creating landforms such as fjords and rias. Both fjords and rias are drowned valleys, so they have that in common, okay? They're both drowned valleys. Now, a ria is a river valley, whereas a fjord is a glacier valley. Fjords are found where glaciers over-deepened valleys or made valleys extremely deep until they were below sea level, while rias occur in valleys which were formed by rivers. Very simple. So that's a little difference there. Fjords are long, narrow inlets with high cliff-like sides. Okay, they're very deep apart from a shallow entrance. So again, the ice comes down through the landscape. It pushes everything ahead of it. All right, then when it hits the sea, all right, or hits the end of itself, it usually floats on the ocean, which means the original bits are scooped out. Think of like scooping out a big thing of ice cream. Okay, you make a big deep channel, and then you lift up towards the end. So there's a shallow entrance to our fjords, but then very, very deep after that. Rias are more like winding channels with relatively low, gentle sides. Okay, so a ria will actually look like just a very wide river. The depth of a ria increases towards the sea. So again, if we were to compare, okay, look at our ria here, it actually looks kind of just like a river, okay? But if you were actually to like map, if you were to drain all this water out, that would be a valley going down into a V shape with the river, the original river, flowing along the bottom. Whereas this, kind of tricky to see, this is our fjord, okay? Very dramatic mountainsides, okay? And here's our channel of water flowing through there, okay? So this is the glacier scooping all that land out, okay? What we're going to do is we're just going to jump over now. There's a couple of pages in Bahamian Landscapes. Page 106 is where we're going to start. Okay, so we're done with our fjords and rias and raised beaches. Now they're found around the world. So what we're going to do is we're just going to look at a couple of other features that happen now in the Bahamas. All right, our last couple of features. So let's jump straight in. We get storm beaches or storm berms. Now that word berm we defined the last day, alright? So it's kind of like the back top of a beach. Okay, the highest ridge usually towards the back of a beach. So the lasting effects of storms and hurricanes are not always realized, nor is the frequency with which they occur. Storms are the most important builders and destroyers of the coast. Okay, so they lead to huge levels of erosion, which generate huge amounts of sediment, which is later deposited somewhere else. So storms actually play a very, very important role in shaping and rebuilding and destroying our coasts. Okay. All right, page 107 then. We now must consider the effect of these forces. So essentially they have enormous lifting and transporting power, and on the coast will operate at a significantly higher level than normal sea levels. All right, so there's a couple of reasons why storms are so effective at changing our coastline. All right, first of all, storm conditions, sea level will rise. All right, so obviously our sea level will rise, so land that wouldn't have been eroded before is now being eroded, so there's even more sediment being created. A condition known as storm surges, okay, where the sea level gets very, very high. A new level of about 3 meters higher than the high tide will be established. So all of that land that would never have experienced coastal erosion is now getting absolutely battered by these storms. Okay. Waves will be very high, 3 to 4 meters. Okay, so again, you've all seen it looking out your window. The storm waves can be huge. All right, so higher tide levels, they will pass over protecting reefs and banks with ease and bring the most severe conditions to the protected land. So even our reefs and our mangroves and stuff will struggle to protect against waves this powerful and this frequent. All right, so we have higher sea levels, all right, affecting coast that wasn't ever affected before, and then you've got bigger and stronger waves essentially, which aren't slowed down by our protective reefs. Okay, it should also be noted that erosion or damage created will increase as the square of the wind speed. If the wind speed doubles, the destructive power quadruples. All right, so again, that's explained quite simply here with an analogy about coconuts. All right, so if the wind speed doubles, okay, then the waves will hit twice as hard but also twice as often, so it's 4 times stronger. Okay, this is kind of this is a picture here of a storm beach. Okay, so what you'll notice is it's essentially a beach after a storm. That's all it is. Okay, the sediments will be bigger, okay, and contain more random materials. All right, because they haven't been in the ocean long enough. They've essentially been smashed to pieces very quickly and then thrown around and dumped on a beach during the storm. Okay, so you'll have quite rocky particles, you'll have a lot of different debris and stuff all over the place. Okay, going to move on to the next page. Deposited up to this level. So another feature is not only is land that's never been eroded before, you also having stuff deposited where there's never been deposition before because the sea level is so high. Okay, so all of this can add significantly to the land surface. So actually, once the storm is finished, it can have completely changed the place. All right, and if it deposits a lot of material in one area, it can deposit hundreds of tons of material which could form new land. All right. Andros, all right, along the coast there is a wedge of soft sediments up to 4 meters that is almost entirely due to storm waves during the last 15 years. Okay, so Andros is actually arguably getting bigger on one side. There's hundreds of miles along the coast where there's a wedge of soft sediments up to 4 meters. So if we wanted to, we could probably backfill that in. Okay, more striking is the boulder sized material that is swept up in great banks behind the regular beaches or even on top of low land. All right, this is what forms our storm beach or our berm. So again, the material is pushed way further up the beach onto the back of the beaches, up even past the dunes or on top of the dunes. Now that material, okay, it'll remain in place almost permanently because there's no other forces to remove it. Maybe the next storm might shift it a bit, but what you end up getting is this build-up of storm material essentially way high up on the back of beaches. All right, because the waves were powerful enough to push them back up there. All right, so that's our storm beaches. That's another feature which we do get here because we have storms. All right, We're going to look at a little bit of beach rock, and then we're pretty much done.